In this video, we're going to classify the different types of bonding in solids. And the bonding in solids can be classified by the types of attractive forces. And remember, when we have solids together, the atoms are packed really, really tightly. So since they're packed really tight together, the attractive forces can lead to some very interesting properties that we don't see in liquids and gases. So there are four general types of solids that we're going to look at. They're molecular solids, covalent network solids, metallic solids, and ionic solids. So the first is molecular solids. And in molecular solids, our intermolecular forces are weak. Okay, these are soft. They have a low melting point, and they're non-conductive. Typically, we observe these as a liquid or a gas at room temperature. And some examples we could see are helium gas, water in its liquid form, and CO2 as a gas. The next form is covalent network solids. And covalent network solids are atoms are held together in 3 dimensions by covalent bonds. The properties, these materials are very hard and they have a high melting point. And the entire crystal is one kind of big giant molecule. And some examples of these are diamond, where carbon is in the sp3 configuration. Also silicon, germanium, and gray tin are examples of this. And also graphite is an example of a covalent network solid. And here we have sheets of carbon held together by intermolecular forces between the sheets. The third, we have metallic solids. And in metallic solids, we have an array of metal cations held together by mobile electrons. And sometimes you'll hear this characterized as the electron C model. We have a strong attraction here depending on the size of the cation and how many valence electrons we have. So with these, we have a wide range of hardness and melting point. These are excellent conductors, and these are very malleable and ductile. The last type of bonding that we see in solids is ionic solids. And in ionic solids, we see an ionic bond between the cation and anion. This bond strength which we refer to as lattice energy is going to be proportional to the charge of the cation times the charge of the anion divided by the distance between them. And a lot of the properties depend on this lattice energy. Okay? So, for example, the melting point of NaCl is equal to 804 degrees Celsius, while for magnesium oxide, the melting point is 2,826 degrees Celsius. Okay? Here when we go from NaCl, we have a +1 and a -1 charge, where magnesium oxide has a +2 and -2 charge. So we see a drastic, increase here in the melting point. These are actually hard and brittle. Solids here are non-conducting, and liquids exhibiting this type of bonding are conducting. And in the textbook, you can look at the various unit cells and the structures of all these ionic solids, and we'll definitely talk about those in class and show some figures showing that. So if you have your textbook in chapter 12, make sure you look at all the structures and you can visualize in your mind the shapes of all of these ionic solids, because they can become very, very difficult to draw. So this kind of summarizes all the bonding in solids, and we can look at all the properties of solids and kind of classify them into these different groups, and can kind of justify why we see such a wide variety of properties in solids.